For this next part of the lesson, we're going to deal with what's called a composite function. Now, composite functions can tend to get confusing if you let them, but what I want you to do is I want you to think of this as one big substitution problem. Now, you've actually done substitution in functions before, so if you recall, let me give you an example problem of something that may look familiar to you. Let's just pretend that we had f of x equals to x plus 3. And we said that we want you to find f of 2. Well, you know that that 2 is replacing the x everywhere in the function. And I'll keep my color coding go so that you can see the substitution take place. So now we know that f of 2 simply equals to 5. And you remember that's how we taught you how to evaluate or find inputs and outputs, and that gave us an unordered pair on the given function. Now, here's the thing. We can take that same process and let's use the same function. Let's say f of x equals x plus 3. But now, instead of replacing x with 2, let's say we want to replace x with an entire other function. So maybe we want to replace x with x squared plus 3. So you can see here we could define x squared plus 3 as another given function. Maybe we might say that g of x is equal to x squared plus 3, when we would simply plug that in. And so what would happen here is this. Every place that there was an x in the original function f of x, we would replace it with x squared plus 3. But don't forget, we have the plus 3 on the back end of this. So basically what we've done here is we've replaced the x with x squared plus 3. Now, we would combine like terms and we would have our new composite function. So basically what we said here is we put g of x into f of x. And so basically the way we write that is the f of x, the x part, was actually replaced with the g of x. Now, if you look at the key concept box, you can see there's multiple ways to write this. Now, keep in mind, f of g of x, that's how you say it, f of g of x is not the same as g of f of x. The difference between those two would be that which part is going in, which function is going in the other function. So, but remember that this is just a big substitution problem, and then once you substitute the function inside the other function to create the composite function, then you just combine like terms and simplify as you normally would. Okay, so let's take a look at a couple examples here so that you can get a better feel for this. The way I like to look at this is kind of like the old Russian doll sets, where you just put one doll inside of another, and that's really basically what I want you to think about. I also like to use color coding here because I think it shows the substitution a lot better. So if you look at example number 3, I'll just focus on part A to start. We're finding f of g of x. We were given both the functions, and so we want to replace the x in f of x with the g of x function. So I've used the red color coding here. So in place of x, I'm going to use the entire g of x function, which is 2x minus 1. Now, we're raising the 2x minus 1 to the negative 1 power, so to make that positive, we're going to push it into the denominator. And you can see the substitution take place there. Now, if you look at part C, notice we have f of x, which is simply putting the current function into itself, and so you can see that substitution take place there. Now, you may see on Math Excel the notation written a little differently, and so you may see this little notation with a little degree looking bubble, and it almost looks like fog. So remember that this is the same thing as that. And so that's the different types of notation that you could see in various applications. So just keep that in mind. Alright, so let's try sample problem number 4. Go ahead and see if you can work through A, B, and C real quick, and then come back and take a look at the solutions. Okay, I've set up sample problem part A here, and you can see very simply that I'm replacing the x and f of x with the other function g of x. So every place that there's an x in my original function f of x, I'm going to replace it with the entire function of g of x. So you can see that take place. Then from there I would simply, and that is our composite function. So here we've reversed this process and we're doing g of f of x. Again, I've set it up with color coding so you can see the substitution take place. And I'll go ahead and simplify from here. Okay, and this is a good example here. You can see that f of x, f of g of x does not necessarily equal its reverse composite, so g of f of x. Now, sometimes it will, and we'll talk about how that is and why that is in the next lesson when we start talking about inverse functions. But it does not necessarily equal those, and you can see that between those two parts right there. Alright, and last, let's do f of x. Alright, and you can see that we end up simplifying just simply to x whenever we substitute f of x inside of itself. Alright, there is a good few examples to introduce you to composite functions. I think by far this is the most confusing type of problem that we deal with in this lesson, and it is one of the most popular types of problems that you'll see on the ACT in regards to function operations.